This is Unit 12, Lesson 7, Part 1. So in this lesson, we are going to be given a triangle with some pieces that are missing and some pieces that are given, and it's going to be our job to determine whether the law of sines would be a more appropriate method or the law of cosines would be a more appropriate method. Now, it's not going to be like, oh, I decide that I want to use this one right now. The information that's given to you is going to help you determine which is the appropriate method to use. So that's the first information that I'm going to give to you is in these two boxes right here. So here is a quick recap of the law of sines. Sine A over A, and then those ratios are all equivalent down the line. So law of sines you would use when you are given an angle side pair. Okay, so if you have angle A and side A, or both B's or both C's, all right? So the two scenarios where that will pop up is, I'm sorry, three scenarios that will pop up. If you have angle side angle, if you have angle angle side, or if you have side side angle. Okay, so two different ways to have two angles and a side, and then one way to have two sides and an angle. So those are the two scenarios that you could be working with, where you have one angle side pair and then another piece. So like angle side angle, for instance, could be if you have angle and then like this side, this would be like C, little c, and angle B or something like that. And then you could also have angle angle side where you have capital A, capital B, and then little a. All right, so a couple different options. And then side side angle would be if you had like A, C, capital A. Law of cosines seems like it's a pretty complicated rule here, but remember, it's just kind of a repeat, swapping out the A's, B's, and C's. You use when you are given either the side angle side case, so very specifically two sides with the angle that is in between them. Okay, so two sides with the angle that is in between them, or the side, side, side case. Okay, so in this instance, you do not have an angle side pair. Okay, you either have all three of the sides, which means you don't have a pair, or you have something like A, angle B, and C, which means you don't have a pair. Okay, so just keep this in mind. You do have an angle side pair, you do not have an angle side pair. So that is always what we're going to be looking for. So a couple of examples on this first page. We're just going to be finding one missing piece. First, we're going to indicate which law makes the most sense. So we're going to look at example number 1 first. We are looking for this piece right here. What you have is side, side with the angle in between. So side, side with the angle in between would be this instance right here. That means we're going to be using the law of cosines. We do not have an angle side pair. We only have this, and we do not have the side that's across from it. So that would be the law of cosines that we're going to use, and we will use that to solve for little x. Okay, so x is the side length. We put that in for this first measurement right here, a. So we do x squared is equal to, and then remember the b squared plus c squared means the other two sides squared and added together. So 19 squared plus 9 squared minus, and then 2 times the other two sides. 2 times 9 times 19 times the cosine of that opposite angle to the side that you're looking for. So that would be 39 degrees. When you're using the law of cosines to solve for a missing side, that's the easiest possible way to do it, because all you have to do is just take the whole right-hand side and just plug it into your calculator. All right, so 19 squared. Oh, quick reminder, always double check that you are in, double check that you are in degrees before you set everything up. So plus 9 squared minus 2 times 19 times 9 times the cosine of 39 degrees. Okay, so write down a bunch of decimals, at least 4 preferably here. So 176.2161. And then to solve for x, we take the square root. And remember, we normally do a plus or minus, but in this scenario, we only count the positive version because we know we're referring to a side length. All right, so we're going to take the square root of 176.2161. So rounding to the nearest tenth would be 13.3. Okay, next one like this, we'll do number 3. Our given information here, you see what we're trying to solve for. We're looking for this angle. We have the opposite side. We have this angle with this side, so that is a pair. Of the given information, we have a pair. So that immediately tells us that we're going to use the law of sines. All right, so let's set this up. So sine of the given angle over the given side. So these guys have to be paired together. They have to be opposite of each other. Equals sine of that missing piece, the x, over its opposite side. Would be 8 right there. So that's the setup that we use for the law of sines, and it all comes back to this right here. The opposites have to be paired up in our little ratio. So now we solve for x. To get this by itself, we multiply both sides by 8. So these guys cancel. I'm going to plug this left-hand side into my calculator. So I do 8 times the sine of 112 divided by 18. Make sure you close the parentheses before you divide by the 18. So I'm going to write down a bunch of these digits. I'm going to write down 6. So 0.412082. Okay, so remember that's the sine of x. The sine is a number that's somewhere between -1 and +1. And in the law of sines notes, we talked about the ambiguous case where you could potentially have 2 different values. So we want to make sure we're checking for that. Your calculator will automatically give you the one that's in the first quadrant. So watch what happens here. I do inverse sine. So inverse sine of this value right here. So I get 0.412082. So it gives me 24.3. So 24.3 is the one that's in the first quadrant. That's the one that the calculator automatically gives me. So we know that one's going to work. Like that's definitely an answer. But there's a possibility that I might have, so like here's your 24.3. I might also have whatever this angle is because they have the same exact reference angle. They would have the same exact value of sine. It's just the calculator automatically gives you the first quadrant answer. So to find the second quadrant answer, I subtract this from 180, and then I see if it'll work. So 180 minus 24.3 gives me 155.7. Now the way I determine if this is going to work is to see if this angle will fit in a triangle with the angle that I already know. And they will not. They are both obtuse. You can't possibly fit 2 obtuse angles in the same triangle because you only have 180 degrees to work with. So this one does not work. Only this first quadrant angle will work. Okay, so that's how it's working so far. On the next page, we're going to do something called solving for triangles. And that means we are going to be finding every missing piece. So the strategy starts off the same. We might be using some different techniques. So on this page, we're going to do numbers 5 and 6. So solving a triangle means finding everything that's missing. They give us 3 pieces. We have 3 pieces left that we need to solve for. So use the information. Let's set this up here. So we have a 47-degree angle that I'll put right here. Angle B is a 52-degree angle, which I will put right here. And then AC is 13. So this is C. That's our missing angle that we'll need to find over here. AC would be this line right here, and that is 13. So we don't have that, and then AB and BC are our missing pieces right here. So line AB would be this one. Line BC would be this one. So those are our missing pieces. So the first thing, in my opinion, that's easiest to find is a missing angle. If you have 2 angles, it's very easy to find the third one because you just subtract from 180. So angle C is just 180 minus the 2 angles that you already have. So that is very straightforward because you know that altogether they have to add up to 180. So 180 degrees total minus the 2 angles that we already have. That leaves us with 81 degrees for angle C. So that part is pretty straightforward. Okay, so we've got that piece first. And then if we look and see what we have, so like now we can just start filling in the blanks. Now we know that that's 81 degrees. I have a pair. From what I was given in the beginning, I have a pair right here. So we know that I'm going to be using the law of sines. Okay, if you have a pair, you're going to be using the law of sines. So let's set that up. So the sine of 52 degrees over its opposite side equals, so let's solve for this missing piece first. Okay, because like this was given to me, so I can find that. So the sine of 47 degrees over x, that's my missing piece. So I am going to cross multiply if I'm solving for x. Cross multiply here, I have x times the sine of 52 equals, then cross multiply here, I have 13 times the sine of 47, and then divide both sides by the sine of 52 to get the x by itself. So these will cancel. We get x equals, make sure this gets typed in just like that we're not, canceling the signs or doing anything weird. So I have 13 times the sine of 47 divided by the sine of 52. Remember, it's okay if the coefficient kind of ends up by itself like that. Just make sure these two pieces are divided. Round to the nearest tenth, that would be 12.1. Okay, so this side right here is actually BC, so that is 12.1. And then we have one more side to solve for. So this, you cannot do the Pythagorean theorem. This is not a right triangle. You cannot do the Pythagorean theorem. It would be much quicker, but unfortunately we cannot. All right, so now I put in, I know my 12.1. So this is my last missing piece that I have to figure out right here. So you can either do law of sines or law of cosines to find that missing piece. It really just depends on which one you find to be easier. So we might as well just stick with the law of sines since that's the one that we were just doing. So keep this same setup on the left. And then use the opposite, the other angle here, the 81. So sine of 81 over, let's call that other missing piece y. Okay, so same exact thing that I just did here. Cross multiply, I get y times the sine of 52 equals 13 times the sine of 81. Divide both sides by the sine of 52. And I will plug that expression into my calculator. Okay, so round to the nearest tenth, I get 16.3. Okay, and one final problem right here, number 6. We've got a triangle XYZ. Okay, so we will have angle X, Y, Z. Those are my missing angles. XY is 29, YZ is 22, and XZ is 21. So this is a side case. That means that I am doing law of cosines. Okay, I have to do law of cosines. Now here's a trick. When you do that, you want to start with the angle that you know is going to be the biggest angle, okay? Because I have 3 angles that I need to find, and so a lot of people are like, well, which one do I start with? Start with the one that you know is going to be the biggest, and that is the one that would be across from the biggest side. So we're going to solve for angle Z first. So when I do my law of cosines, this law right here, the one that you're solving for, you have to make sure that the opposite side is the one that's on the left-hand side of this expression. Okay, so I will plug in 29 squared is equal to, so square the other 2 and add them together, minus 2 times the other 2 sides times the cosine of that missing angle, which is a capital Z. So remember this one, you cannot just plug everything into the right-hand side here. That would be lovely, but unfortunately we can't. We have to kind of take everything and go piece by piece. So I can do 29 squared, so 841 equals, I can square those 2 and put them together. I get 925 minus, and then this last piece, 2 times 22 times 21 is 924 times the cosine of Z. So remember, this is attached to the cosine of Z. You absolutely cannot subtract those 2 numbers. You will get a very wrong answer. So I solve for this piece. First thing I do here is I subtract the 925 from both sides. So I have 841 minus 925, and that leaves me with a negative 84 on the left-hand side. I still have negative 924 times the cosine of z on the right. Divide both sides by 924, so negative 84 divided by negative 924. And that leaves me with this. Remember, keep a bunch of decimals. So 0.090909 is equal to the cosine of z. So that gives me the cosine value, which we know is always somewhere between -1 and +1. And so in order to get the actual value, we need to take the inverse cosine of both of those sides. All right, so inverse cosine of 0.090909. Okay, so I get 84.8 degrees. So that's one piece. That is 84.8 degrees. Now we have a pair. We have angle z and we have side z. So now we can set up the law of sines to find the other piece. Okay, so I'm going to do sine of 84.8 over its opposite side, which is 29, equals, and then I'll do the next biggest. So if this is 22, then we know that'll be the next biggest. And then solve for x. So multiply 22 over to the left-hand side. Okay, so let's plug this whole left-hand side into the calculator. Okay, so 0.75549 is equal to the sine of x. And so I know I have to do sine inverse in order to figure out what that actual value is for my angle. Okay, so 49.1 if I round to the nearest tenth. So that is angle x. And then let's do just a quick check to see if I could fit in the other one. So the other possibility is that it's 130.9 degrees. That can't fit in the same triangle with this 84-degree angle. So that one's out. Finally, I just subtract everything from 180 to find my last missing piece. So angle y, I just subtract the other two from 180, and what I am left with is that third missing angle, which will be 46.1 degrees.